Hello everyone, my name is Zhiyu Zhang. I'm honored to have the chance to address you on this special occasion. The topic of my paper is improving polyphone disambiguation for Mandarin Chinese by combining mixed pooling strategy and window-based attention. The outline of my talk as follows. The first part is introduction, and the second part is method. The third part is the experience, and the final part is the conclusions. So part 1 is introduction. Grapheme-to-phoneme conversation is essential for text-to-speech systems. Mandarin Chinese G2P systems convert Chinese characters to their corresponding pronunciations, called pinyin. You can see this example. The input is a Chinese character sequence, and the output of G2P system is a pinyin sequence, and it means what's the purpose of coming days. For the Mandarin Chinese TTS system, it's essential to develop an effective polyphone disambiguation system to predict the correct pinyin transcription from several candidate pronunciations of the polyphone character according to the context. For example, this character is a polyphonic character, and it can pronounce the or d in different contexts. In this paper, we proposed a novel system based on word-level features and window-based attention for polyphone disambiguation. The framework aims to combine a pre-trained language model with explicit word-level information in order to get meaningful context extraction. The proposed method can effectively avoid the OOV problem and elevate cascading errors caused by the external Chinese word segmenters. The proposed model achieves 99.06% accuracy, which outperforms the baselines on the public benchmark dataset of Chinese polyphonic characters. Then is motivation of this paper. The pronunciation of a polyphonic character is related to the meaning of the word, which carries more semantic information than a single character. For example, the pronunciation of this character in word 倒他 is different from another word 倒立, and the pronunciations are marked as 倒 and 道 respectively. Therefore, we assume that combining the word segmentation information with the pre-trained BERT can improve the results of polyphone disambiguation. Then is method. This is our framework, including a BERT encoder, word segmentation, mixed pooling strategy, word-based attention, and dense of source-max layer. The input is a Chinese character sequence, and this character is a polyphonic character. The output of this system is a pinyin transcription. Firstly, a character sequence is fed into the pre-trained BERT encoder to get the character-level hidden features, like this part. And we can get H. H is hidden feature, character level hidden feature. Secondly, we use external CWS tools to segment X into a sequence of words, like this part. We segment word, and this is a Chinese word. Then we segment H according to the result of tau x, like this part. As a result, H is divided into several sublists, and each sublist includes character level hidden feature of the segmented word. This is a character level list. Motivated by others, we transform the sublist into a word level hidden features with mixed pooling strategy defined as follows. Well, lambda is a hyperparameter used to balance the min pooling and the max pooling. For each sublist, we can obtain a word hidden feature layer list, big H. This is a big H word level hidden feature list. Some work shows that information between neighboring words and polyphonic character is essential for polyphone disambiguation. Therefore, we use n-word window to improve neighboring information extraction in our model. Well, H is the center of the sequence and its left and right neighboring words word level features with a set of n are considered as the context. Then we introduce window-based context feature as from big H as follows. This is the n-word window, and this hidden feature is a center feature, and the left and right is context. In our world, we use a feed-word attention module to associate the polyphon's character level feature derived from BERT with the context feature. For each word level feature, the attention weight is computed as this, and then the weighted embedding can be calculated as this. After obtaining the output of attention module, we concatenate it with the polyphone's character level feature. Next, we feed the result into a fully connected layer followed by a source-mapped layer. Finally, the ping probability distribution can be expressed as follows. Then is experience. We use an open benchmark of the Chinese polyphonic character dataset named CPP dataset in our experiments. It consists of 99,000 sentences, each of which includes a polyphone with the correct pinyin transcription. The dataset contains 623 different polyphonic characters, each of which has at least two pronunciations. There are some details of this dataset. Then is baseline of our experience. The first one is an open source Chinese GTP library called Pinyin, which is a rule-based system. The second one, named G2PM, is based on the BERT approach. The third one, named sequence-to-sequence, CNN plus LM, is a convolution sequence-to-sequence model with augmented data by audio-generated text containing polyphonic characters. The last one is a Mandarin Chinese BERT model. We add a fully connected layer to BERT and fine-tune it with CPP dataset. Besides, we compare our model with a new proposal model named TWSP, which achieves state-of-the-art performance for the joint CWS and POS tagging tasks. This model utilizes two-way attention machine to incorporate both the word information and their corresponding syntactic knowledge. We implement it for polyphone disambiguation task by using Chinese BERT as the encoder and combining it with POS labels, syntactic constituents, and dependency relations as syntactic knowledge, respectively. Overall, this is performance. Overall, the proposed BERT MMA model outperforms the baseline systems and achieves state-of-the-art performance with an accuracy of 99.06%. Since BERT MMA is based on the pre-trained language model and word information, it significantly improved compared with the G2PM and the sequence-to-sequence model. We can also observe that the TWSP model is improved performance. However, TWSP randomly initializes the embedding for the word and the features, which can easily lead to the OOE problems during the inference. By contrast, BERT FFA utilizes a mixed pooling strategy to convert character level and feature into word level features, which can effectively avoid this issue. There are some other performance evaluation. This is a operation study. The result shows all components of our proposed model are necessary for achieving the highest accuracy. Since the result of word segmentation has a great impact on polyphone disambiguation, we employed 4 popular CWS tools as taught in our model. Our model achieves better performance regardless of the CWS tools comparing with BERT-RC, which confirms the effectiveness of our proposed model. We also analyze the influence of the word window size by increasing n from 0 to 3. We explore different ratios of mixed strategy by changing the interval from 0 to 1. The highest accuracy is obtained when lambda is set to 0.5. Finally, in this paper, we propose a novel BERT MFA model based on mixed pooling strategy and window-based attention to improve polyphone disambiguation for Chinese G2P conversation. From the experimental results on the benchmark polyphonic character dataset, BERT MFA significantly improved the accuracy by over 1.2% and achieves better performance for polyphonic characters with disambiguation imbalance or data accuracy comparing with the winning Chinese BERT. Moreover, BERT MFA can avoid the OOV issue and alleviate cascading errors caused by CWS tools effectively. Future work includes improving our method to Chinese dialect and incorporate multiple types of knowledge, like POS labels for our proposed model. That's all. Thank you very much.